All right, I'm gonna work on a few problems with you guys on this review sheet that has 60 some odd problems. If there's any others you wish me to do, just email me or reach out to me on Google Class or whatnot. 1 through 5 is definitions. 6 through 8 we write in exponential form. So let me just define that once again. So log base b of some argument y is equal to x. That is equivalent to stating your base to the x power is equal to y. So 6 through 9, you're just rewriting it. 10 through 25, evaluate without using a calculator. You do not have to rewrite these, but if you did, what happened there? If you were to rewrite them, 10, for example, would be rewritten as 3 to what power is equal to 243. In this case, 3 squared is 9, 27, 81, 243. X would be 5. So 3 to the 5th power is 243. So it's optional to rewrite it. You don't have to, but if you're unsure, it may help you. Expand each expression. All right, properties of logs. Let's throw those out there. So log of a product is equal to sum of the logs. All right, looks like that. Log of a quotient is equal to the difference of the logs. And one more property. If there is an exponent up top, you can bring it down. So n times log of a. So let's see. Let me do 31. I'll do 31 with you guys. All right. So for 31, log base 3 of 27, log base 3 of x squared, log base 3 of y. Already got a space. Log base 3 of z. 27 and x squared up top. So those are positives. So we don't need to put that guy there. Y and z are on the bottom. So those have a minus in front. And last thing to do is bring that power of 2 down. So that term would be 2 log base 3 of x. And that one is expanded. All right, 32 through 34. You want to condense these. Before you can condense any of them, you have to bring up any coefficients that are in front. So I'm going to do 32. So let's bring that guy up. So log base 7 of 4 cubed plus log base 7 of 6. So using the properties we just stated above, just in reverse, we can do that. So 4 cubed times 6, 64 times 6, what is it? 4, 2, 6, 384. And that is that answer there. All right, next group of problems, 38 through 43. So all you are given is log base 3 of 4 and 7. So we want to rewrite all of these in terms of those two only. So 38, we know 28 is 4 times 7. We know we can expand that. We can now replace the first one with 1.262, the second one with 1.771. And we will get, that's 3, 7 plus 6 is 3, carry the 1. 0, carry the 1, 3.033. Double check the arithmetic when you have a chance. I'll upload the key later and you can verify your answers. 16 is 4 squared. So this one we have no need for the 7. So it'll be 2 times 1.262. 2. So let's go ahead and double all this. 6, 2, 4, 5, 2. Again, double check that just in case. Or in fact, give me a second. I'll type it into my calculator on my phone real quick just to verify this. 2 times 1.262. Yep, that one's good. 1.262. Yep, those are good. Okay, next section down here. Oh, I moved my screen. I didn't want to do that. Put that back. All right, let me pause this for a second. All right, back on. Change of base. So I believe we discussed this briefly before the break. If not, here is the change of base formula property, if you will. So any logarithm, we can rewrite it as a quotient of logs. The argument is the argument of your numerator. The base is the argument of your denominator. The new base, as long as they match up, are your choosing. So whatever you want C to be, that's what it'll be. All right. So for example, 44, 12 is the argument up top, 7 is the argument on the bottom. You would type that into your calculator. Base is your choosing. So whatever you want to pick. Most common ones are going to be your natural logs and your common log, where it's log base 10. But the base is your choice. All right, 48 through 49. For these, you want to set them up so that they have the exact same base. So say they both have the same base of A. Once you're able to set up your equation like this, then you take your exponents and set them equal to each other and solve. So it's just properties of exponents for there. All right, so I'll grab that. Just want to scroll down. There we go. All right, 51 through 52, or 51 and 52 anyway. Similarly to the previous three, once you have the same log in front, just set your arguments equal to each other. So 51, we'll just take the arguments and then solve for x. 53, isolate the log, rewrite as an exponential, solve from there. And that is in some previous notes, some previous assignments we've done. In fact, the rest of this stuff is relatively new. 54 through 56, check D3, D4, D5. If you're still unsure, please reach out to me and I'll gladly go over them with you. Graphing some transformations. So start with your parent function and just shift accordingly. So as with all transformations, let's see, A times, we'll do B, we'll do C there, plus D. So if you recall, guys, adding on the outside shifts it up. If it was subtracting, it would shift it down. Subtracting on the inside shifts it to the right. If it was adding on the inside, it sent it to the left, having the adverse effect. Multiplying on the front, that's a vertical dilation. So you'll multiply the y coordinates by a. If it's negative, it's going to change all your y coordinates, the signs of them, thus reflecting it. I don't think you have anything regarding b, but if you did for b, you would take your x's and divide by b. It'll be a horizontal dilation by a factor of 1 over b. Again, having the adverse effect. So I will start with your parent function and shift accordingly. Let's see what else we have. Word problems. So this is D5 or D4, I forget which one. So we just worked through those. If you need me to go over any additional ones, let me know. All right, for this recording, I'm gonna upload it to YouTube and see how that works. I'll add the link to this assignment. Hope y'all are having a good day, having a good week, and finding time outside to be somewhat productive in this strange times you're in at the moment. All right, signing off.